first passive house?
Our first passive house.
And Lauren Coburn, the interior designer. Introduce yourself.
I'm Lauren Coburn. I have my own residential interior design business. I've had for 22 years. And I'm also thrilled to be part of Next House Alliance as the
So that's great. And then, of course, we have Margaret Stender, who's the owner. And Margaret, so Margaret is, I met Margaret, she can introduce all this too, but I met her on the Evanston Bike Club. We just got done with a ride like an hour ago. Margaret is the founding CEO of the Chicago Sky basketball team and one of the nicest people I've ever met and very inquisitive about this, and I'll let you talk a little bit.
Welcome to my almost home, right? I am so thrilled. I was telling someone yesterday, I spent my whole life in really old homes. I grew up in a colonial home in Virginia. Then I moved downtown in Chicago and I live in an old Victorian home. And, you know, so I decided time for a big change, everything new. And so and I'm of course really concerned about our planet, as I know all of you are. And so I was lucky enough to find this lot. And then I just started Googling who is expert in environmentally sustainable homes. And that got me and led me to Nathan before I even knew he was a biking guy. And his team has been extraordinary. It's really a collaborative endeavor because the passive house certification, as you all know, affects every single thing that we're doing, all the materials that Lauren has to select, all the things that the construction team has to do. So it's really an integrated process. And I've learned a ton, and these guys are expert. And so anybody, welcome. Feel free to ask any questions. I guess I'll just say design-wise, this is my forever home. So there's only one way that I'm leaving this home, and I hope it's a really long time from now, but you know, and it's really right-sized. I have two adult children and then just me, so it's not a big home. It's 2,800 square feet. It looks bigger from the outside than it is. Nathan will tell you why that is, and every space that we have in here will be very actively used, meaning there's no, wasted rooms where nobody goes into.
No ballroom?
You might have those in your house. I certainly did. This house won't be like that. No basement, because I don't need a basement. And the idea was kind of outside in, inside out, and you'll see all the design elements that contribute to that. I couldn't be more thrilled.
So we're going to stay out here for just a little bit. Before we start, who here has either worked on a passive house or is involved in the passive house industry? Okay. Who here are architects? All right. And who here just is very curious about this house? Everybody. That was a trick question. Okay. So one of the really interesting things is Margaret said, I want a modern house. And she got this lot, which obviously is in the historic district of Evanston. Evanston has a very strict, it's not a code. You don't have to follow it, but you really kind of do. I've been working for 30 years, almost all of it, 29 years in Evanston. And we've done a number of homes in the historic district, but they're usually historic homes that we're working on. So because this is a new home, it does not need to follow the guidelines, but it needs to follow some things. And some of these things are how the house relates to its neighbors. So even though this is super modern, the home has a lot of features that the neighboring homes have. So you notice there's a bay here, and if you look, most of the homes have bays, and they have a major section and a minor section. The bay is centered. It penetrates through the roof plane up there, but it's doing it in a very modern way. It also has a porch in the front. Well, what's different about this one? It doesn't have columns, so it's cantilevered. We also had to match or relate to the other buildings as far as the proportions. So in other words, the height to width of the windows, very similar to all the other ones here. Same with the height and width of the main sections of the building. There's a drawing on the inside taped to these windows here that shows all those alignments. So even though this is very modern, you could almost envision the trim going on if this wasn't an asymmetrical bay. This would fit right in. And so initially we got a lot of pushback, but the point I was trying to make with a historic neighborhood is when you go through it, you want to know what you're looking at. You want to know these are correct. You know, that house is from 1895 and this one's from 1920. This should not be a fake old home. This should be of its time, so it is. Margaret mentioned the massing of the house. We put the 2-story part in the front to relate to the others. We only have a 1-story section on one side in the back, and we'll look at that when we go in. The thing about passive house is it's super tight, so very few air changes per hour. It's super insulated, and we have a very strict standard of how much energy per square foot we can use in the winter and in the summer. And so to do that, we make the house really tight. A historic home, a vintage home, probably has 8 to 10 air changes per hour. Every hour, the entire volume of the house is being swept out. You're heating it and it just leaves and you're heating it. And you feel that in the winter. You feel the drafts and everything. A modern house might be 4 or 5 air changes per hour. The current code is 3 air changes per hour. Our best house we did previously was 1.1. Passive house is 0.6, and for a lot of reasons we had to be even better than that. This is going to be 0.3 air changes per hour. So yesterday we had some tours and I made the analogy, it's like a submarine. That's a bad analogy all of a sudden, so we won't use that. But basically it's 30 times tighter than the neighboring homes. Now you might go, oh my God, that's so tight, like you're gonna die in there. It's like being in a box. So there's an air-to-air heat exchanger that brings in air in a very controlled, efficient way. And so that's the main way that we do that. And then the insulation system, well, while we're talking about the air sealing, we did a liquid applied membrane. So when you go buy houses and you see Tyvek, that's that floppy kind of woven material. This is painted on, and you can see, I told them we need to go over the nail holes. So we even did that. We're gonna get the house checked with a blower door test. That's when we put a curtain on the front. There's a fan on there that blows air, and it knows we know the volume of the building. We can see the static pressure of the building. We know how many air changes is going on. While that test is being done, we can go around on the inside and see where there's, like, if you can feel, or with smoke, you can see where there's air coming in. So this is really going to be a tight house and really efficient. The other thing about it is it's all electric. If we want to decarbonize, why would we use any fossil fuel? So decarbonizing, what does that mean? The thing that most people flip out about is the induction cooktop. I think it's the best thing ever. So an induction cooktop, and then a lot of heat pump technology. This is different than you know, like resistance heating and stuff like that. So it's super efficient. That's the water heater, the dryer, and then of course the mechanical system. So we use an air-to-air heat pump, an air source heat pump, mini split, as opposed to geothermal. Geothermal's in the ground. We've used those. I'm not as excited about those as the air source heat pumps. I think that finally the technology is exactly where we want to see it. So that's the main systems, and then we have renewable energy to supplement all that. So this house has quite a few solar panels. I don't remember the number, but there's a bunch on the main building, and there's another set on the garage, and then there's space for battery backup. We may or may not put one in. We have room for 4. Those would be 20 kilowatts. So what does that mean? Well, a typical house uses maybe 30 kilowatt hours a day. An efficient house might use 15. A really efficient house might use 5. This one's probably less. Just for reference, I have a Tesla Model 3 that has a 75 kilowatt battery. So there is this theory, and I've talked about it for many, many years, about when the power goes out and you have an electric car, you can plug your car in and power the house off the car. Well, if you have 75 kilowatts and the house uses 5 a day, that's pretty good. And then the panels will supplement it, the solar panels. And then, of course, in the garage, there's EV charging as well. So kind of just embracing the whole notion of going all electric, getting away from fossil fuels. One of the problems with using natural gas and trying to be efficient with it is they're not incentivizing us to do that. You just pay a service charge. They've learned that it's really a pain in the butt for them to, oh, you're using less energy, now we're gonna charge you less, and they're like, forget it, you're just paying this. And we don't like that game, so we're just saying, fine, we're not gonna use natural gas at all. So we've been doing that for many years now with the homes we do, is not to have a gas line. The other thing is on the exterior, we have exterior insulation and insulation on the interior. The reason we want to have exterior insulation, we want continuous without any thermal bridging. If you see a house in the late fall, you'll see vertical lines if you go out in the morning on the house. That's the studs that you're actually seeing sending their heat right through the building. So this eliminates that. Plus it's kind of a technical thing, it moves the dew point to the exterior of the building. So even if we ever had condensation going on, it's outside of the building. When we go inside, I'll show you the way the studs are. It's a very interesting system. And another thing is these are Sierra Pacific triple glazed windows. So, walls are really heavily insulated. The code is something like R25, and I can't remember exactly what this wall is. It's about an R60. And the roof code is about 49. I think we're at 70 something. But the windows are kind of the big sore spot. So double glazed windows, you're lucky if they get to 3 1/4, 3.5. These are triple glazed. They're something like 5 1/2. And it makes a big difference because this is the big hole in the building. So that's basically the notion of what's going on the exterior. Are there any questions before we go in? Yes?
I'm just going to ask generally, is it okay to take photos, or would
Oh, yeah.
either of you prefer we do not?
No, you can take pictures.
Okay.
Yeah. So before I forget, another thing is not only about sustainability, but the building's designed for resilience. And what is resilience? Resilience is watching your TV for the last 4 months and watching all the crazy weather events, which we've known are coming. This has not been a surprise. But you see, if you saw when you were coming in, you saw the ice and water shield over the entire roof. A lot of times, people only put that on the bottom 3 feet so you don't get ice damming. This is put over the entire roof. So even when the metal roof, the pack-clad metal roof is on there, if for some reason that ever blew off or had an issue with super high winds, it's still watertight. The foundation is higher than normal. Typically a foundation is 8 inches above grade. This is 1.8 feet. So if we have like crazy flooding, we're buying ourselves an extra foot of protection with that. And when we're inside, if I don't remember to say it, there's hurricane straps that connect the wall framing to the roof system. And the way the wall is connected to the foundation is extra tight too. So this is all for wind, crazy rains. We got the power outages taken care of when the batteries come. So that's kind of the overall concept with that. Yes?
With the heat pump, are you concerned about the efficiency dropping when it gets really cold? I'm a real estate investor, I'm a GC, and the HVAC companies keep saying, like, you need a backup heat source.
Right.
Forced air, gas.
So the way that works is heat pumps, if you have like a natural gas furnace, it might be 80% to like 97% efficient. So 20% to 3% is going up and out of there. If you have electric resistance, it's 100%. You put a unit of energy in, you get a unit out. A heat pump looks at the temperature outside, and on the Kelvin scale, even when it's cold, there's still a lot of heat there, but you're absolutely right, the efficiency rolls off. But it's more moving heat than producing heat. So it's 300%. It's amazingly more efficient. It's not like 5% better, 20%. It's a 300%, it's a 3 coefficient of performance, even better sometimes. But when the temperature starts rolling down to, let's say, below 10 degrees or so, it starts on this line down. When we started going all electric, I'm like such a nerd. I looked up every hour of every month in the winter for 30 years to see when were we below, I can't remember, like -10. And you go back 30 years and you'd see, oh, there's 5 hours a year, and they were either, combined or just kind of popping up. And it would be like that. Some years it'd be 8, some years it'd be 2. It'd be all over the place, but it'd be there. 15 years ago, it disappeared. And I thought, this is great. We're done. Climate change, we're not going to run into that problem. We designed a number of pretty high-end homes like that, and all of a sudden I'm being told this polar vortex is rolling into town for 30 hours. The systems are, these are Mitsubishi ones, they're down to -19, and I'm being told it's going to be 30 hours at -25, and I'm like, wow. All 3 of the houses made it, including one in Lake Zurich that's at -27. There's electric resistance heating elements that you can then program when those kick in. Yes, you are putting a dollar bill in every hour to heat the house on those 2-3 days a year. No question about it. And you're paying some when it's not even that cold, but still. But for the rest of the year, it's about the most efficient thing you've ever seen. So,
Non-factor, really, is what you're saying. It's a non-factor.
I mean, it's something to take into account. Mitsubishi, a lot of these companies now, Fujitsu and Panasonic and all these others have done really well to start to get this down. When we first saw air source heat pumps, they were like to 40 degrees they worked, then to 17, then to 5 or whatever. They're finally down to -18, 19, and in reality a little better than that. Yeah, it's something to take into account, but it's not, I don't think it's a big deal. Yeah, go ahead.
Oh, look, I noticed that you're using concrete on the exterior.
That will be covered up.
Oh, it'll be covered.
Yeah.
Because I was wondering how efficient it would be in extreme temperatures, extreme hot weather, and then cold weather.
Yeah,
Would
so
you have a-
so the question was about the concrete. So the concrete's going to be insulated. We're just waiting to get the final pieces in here. So this will be continuously insulated. As Margaret mentioned, we don't have a basement. We have one little section that drops down. We did that for 2 reasons. One is concrete is a super high CO2, cement in particular, very high CO2 contributor. It's about 8% of global CO2. And the other is if we had a basement and she doesn't need it, we're conditioning all this space that we are like to the nth degree trying to manage. So we really don't have a basement. We have a crawl space down there that just drops down in one section.
Is the first floor the insulated bottom of the thermal envelope, or did you insulate the bottom of the?
I think it's the crawl space. And so I should also point out our CPHC is Scott Farbman. He could not make it today. So I will do my best to dive on some of this stuff. I'm not going to remember all of it, but we do have actually the chart that we used. So when you do a passive house, you get a check mark or an X. I mean, it's real simple. You either meet your maximum cooling, maximum heating, average cooling, average heating, or you don't. And we ran into problems on the max heating. And we then did iterations to try and figure out how to get back up there. It's a lot of numbers, and it's third-party certified, so it's not just us saying this. There's people that have no interest in this. We just hired them, and they're checking everything we're doing. So.
When will the house be ready for blow test?
The blower door test is.
In the next 2 weeks, the first one?
Yeah, so we're basically the tightness, the envelope is really this perimeter. It's not the insulation. When the insulation goes in, that'll be gravy for us, but we're really hoping that everything we're doing on the air seal of the perimeter is really the key thing. Why don't we go in? Be careful coming up here. We'll go inside. Like here's the different roofs and overhangs. And then the diagonal lines are the proportions of the main buildings, and you can see the windows too are like that. So anyway, take a look at this, and you can see the bays and the bays and the, it does relate, even though it's going to be very modern. I think it's going to fit in at the end of the day. I think we spent a good amount of time trying to do this and not just like throwing a house up without looking at it. Yes.
Were the colors chosen strategically for reflection or anything like that?
The roof, absolutely. The roof is a zinc, which is more like a matte silver. We've done probably 7 or 8 homes with metal roofs, and we almost always use that roof color. It's always a good idea to have a cool roof, summer or winter. It just is way better for the building performance. So that's that. And then, yeah, I mean, this is the age where you don't really want dark colors too much. I, bought my car is silver. There's a good reason for that. Yeah, you want to start thinking that way. I also want to point out, you can see it on the side wall here. Those are what's called T-studs. Those are like a truss. And I mentioned outside that we want continuous insulation on the outside. We have continuous insulation on the inside. So we can put insulation right through this wall, and we get continuous insulation. It's a 2x8, so 7 1/4 deep. Another thing to keep in mind is because this house relates to the heights of the other houses, why did they have high ceilings, these old homes?
Ventilation.
Sort of getting it. So it's to let the heat go way up here. I don't know who's old enough from Chicago to remember Artis Gilmore. He was a basketball player. He did a commercial for ComEd. He's 7'3" or something. He goes, not many of you know it, but it's hot up here. So it's true, the heat rises up. It's why these old homes had that before air conditioning. So we did that, and also just because we wanted a darn tall thing. This is actually an 8-foot door. This is just obviously the construction door here. But, oh, go ahead.
I see you have a lot of cantilevers going out. Are they thermally broken at any point, or are you insulating the outside?
Well, it's wood, so it's not steel. So we do have one chunk of steel on the end that we're going to be able to insulate, but everything else, yeah, doing a cantilever like this is not easy. And so the typical rule of thumb is 1 unit out, you go 2 inward. Because of where the stairs are, it actually is going all the way back to where the steel is back there. This stair is a temporary stair. We're going to have a really cool stair when this is all finished. That's just a construction stair. So, oh yeah, go ahead.
Since the ceilings are so high, does that, because you're increasing the conditioned space, is that going to affect any of the efficiency?
So, so the question was about the volume, and is that adding to the conditioned space load? It does. The interesting thing about a passive house is it's kind of like a thermos bottle. So when you put in some heat anywhere, it will even out over time. It's not like a typical home where, boy, you better put it here because it's really losing a lot of heat. It's really contained in here, so the cooling and the heating will both find their way around. The mechanical system is somewhat slow because it doesn't need to be very intense. Like if you go in some homes, this air conditioner is just roaring to cool it off. This is very finely done. It's very slow moving up and down in temperature. Yes?
What are these units in the ceiling?
So
And then what's driving the location of these?
Yeah, so these are lights. So these are, this home has a lot of smart home items. So these are, I think these are the Lutron lights, right? So, and the reason they're located, this is an art wall here. This is general lighting. The kitchen, I should point out what the layout is here. So this is the dining room. And when you were outside, remember I mentioned that this bay was clad in siding? That actually comes inside the building. So this is going to be siding in here. At night, this will look really wild. It'll look like the windows and the wall intersect through that. Upstairs, you'll see it also turns as the bay turns. This is a niche for some cool artwork. And Yeah, so the spacing, we were very careful about where the trusses go and everything. This was all very thought out. A lot of times, if you don't do that, you screw up where the lights are. But anyway, dining room, kitchen. There's a Val Cucina kitchen. It's this Italian kitchen that has a sustainability story unlike any you've ever seen. There's a video online that shows them taking apart all the cabinets. Every piece is recyclable and from recycled material except like 2 grommets. It's really impressive. I went to their factory. They've been doing this since the 60s. This is not new to them. They're very committed to it. The back room is the family room. And why don't we walk back there? We've got plastic film on here, so you're not seeing it, but you can tell it's already lighting the underside of this, and in the winter when the sun is lower, it'll throw the light more into the middle of the ceiling. So you'll get really nice natural daylighting in here just because of that. This is a fireplace, but because this is a carbon-free home, we don't really want a fireplace. So this is a vapor fireplace. It's basically a linear humidifier with LED lights that are correctly colored. It looks absolutely like a fire. The only negative is it teaches little kids to stick their hands in the fire, but other than that, it's fantastic. We'll have the TV here, and the round things you see are speakers. You saw them throughout. The smart home panels are back here. The power panels are here. I mentioned that basement. Oh yeah, there's some handouts here if you guys want any of them. There's a hatch there that goes down to a section of the basement where the batteries and the mechanical system is for the lower level. There's mechanical upstairs as well. And we'll go upstairs in a little bit. When you're up there, you'll see the ductwork, and you'll see some of it around here. It's with mastic on it to seal it, and as opposed to duct tape, which really never works that well. And then we've got lots of, we had to be very careful about the windows with Passive House. We had Scott, the Passive House consultant, in real time, we'd look at the model, and he'd go, oh, you got too many windows. We got too much heat loss through the windows. We need to finely tune that. And somewhere we have the chart that we did. I don't know where it is, but so the windows, at the end of the day, I think this came out great, but we really, when you do a Passive House, you really, really have to watch where the windows are and how many windows you have.
Did you consider any brick treatment to the windows, or is it more so just the triple glaze, you know?
It's like shades?
No, just some type of applied, just pattern or something to...
You know, Margaret had mentioned the wanting to have inside out, so this is all set up to really flow out to, well, to the garbage can here. But it will be a really great patio here. Her workout room is right there and looking that way. The primary bedroom is directly above it, looking that way. Also super lucky, we have a site with a park behind us. So the view is to a park, you know, hallelujah, right?
What's your interior insulation going to be, the cavity insulation this is?
In these walls? So we're using closed cell foam, and we're doing that because we really had to match that. Every project we do, we learn and we keep moving. I think over time we're going to try and, you know, look at the embodied carbon more and more about, you know, closed cell foam versus others. But it's really the best material for us to be pulling this off right now, especially with the vaulted ceiling section. Another thing about the first floor, there's 3 bedrooms, 2 bathrooms upstairs. Downstairs here, I told you living, dining, kitchen, but also there's, beyond her workout room, is a study with a full bath. That study is set up to be a bedroom. The full bath is a 0 threshold shower. So the aging in place, if anything happens, and it's not just aging, it could be a ski accident or something that, you know, you're laid up for a little bit. So when you're walking around, and be careful when you're going in these bathrooms because there's a drop that you can barely see where the shower is. but that's set up to be flush when it's all done. And that front den room opens up to the patio too, so it's all about being able to flow in and out of the space. Any other questions while we're down here? Yes.
With the house being all electric, what's your service size?
I think we're at 400 amp, right? Yeah, so we've done some houses that have had to be 800 amp. Because this is 2800 and because it's passive house, it's not as big a draw, but that is the one thing that really sets apart an electric home, is to do heating with electric. I mean, when you're going all electric, you want to be as efficient as you possibly can. So, but just so we can all get a baseline, a typical house like this, if it wasn't doing this, it'd be 200 amp. So.
Did you guys have a ERV installed for like heat loss?
Yeah, so we have 2 ERVs, energy recovery ventilators for that ventilation. Yeah, did that answer that?
Yeah.
Okay.
I just want to let you know it's 308.
308, okay, so we're gonna be to 325. So why don't we you can just walk around on the ground floor and then we'll reconvene upstairs. There is a Sola tube skylight. We were going to put a regular skylight in that vented, and we figured out the heat loss and didn't want to do that. So a Sola tube, you can put it on the roof, and you can actually bend it down to where you need it. It's going to be in that hallway, because otherwise this hallway is somewhat dark. There's also an attic hatch to go into the mechanical. The mechanical is all in a conditioned space. You never, ever want the mechanical in a non-conditioned space. And I mentioned about the mastic. You can see that on the ductwork, not duct tape. The plumbing is very efficient. It's smaller than normal, so you don't have a lot of hot water staying in there. And the other interesting thing is in the bathrooms, each bathroom has a motion sensor that fires up the hot water pump, so that the second you walk in, it starts firing that up. You do whatever you're doing. By the time you need to use the sink, it's hot water. So, and then it shuts off right away.
Is it a heat pump water heater, I assume?
Well, it's a heat pump water heater down in that lower level.
In the first floor or in the
In that
floor
little
with
crawl space.
The crawl space kind of deep inside.
Right, so it'll start it up real quick right when you walk in.
Does it know if you're only going to use the toilet?
It doesn't, yeah, well, AI, give it a year, give it a week or something, but. So the other thing is, I mentioned downstairs, you can see in these bedrooms, there's that soffit where the bay is. So the siding is coming into those 2 bedrooms, into the ceiling and down the side. It'll look really cool when that's done. Yeah, we were just very careful about where the windows are located. So the bed is going to be here. You can see that park right out the window here. It'll be really great. And while you're here, you can see the garage. So the garage matches the angle and overhang and all that of the main house. That's where all the panels will be on these 2 sets of roofs.